I do in this unit is point slope form. If you've been walking by it, my little Algebra 1 posters there that are not just decoration, they're also big math. But you've been walking by it all year. The way I teach point slope when I do this in Algebra 1 is that I teach it as a fill in the blank. So in case point slope is something that I don't know, maybe your Algebra 1 teacher didn't teach, because there are other ways to teach equations of a line. In case it's something that your Algebra 1 teacher didn't teach, or that that you don't remember at all, I write that fill in the blank, and then the slope goes in the middle. X goes by X. X goes by X, Y goes by Y. Is how I remember where everything goes. Because once you have that fill in the blank, you just gotta put stuff in the right spot. That's a big deal for calc. We are going to be using it here on this first example. There is going to be a question on your quiz where you have to write the point slope form of a line. But when you're doing tangent lines in calculus, you can't do a tangent line without point slope form. Okay? So don't want Mr. Schaefer, or Mr. Graham, or whoever is teaching calc next year to have to teach people who are in honors pre-calc the equation of a line. They will review it. Also, standard form of a circle, I just wanted to give you that equation. We talked about it on that last day of notes that we did. I just wanted to make sure I formally show you that equation. Again, some of this does pop up every now and again on the ACT, so it's good to be, you're given an equation and you can just pull out the center, pull out the radius, and that, answers that for you, then that's good stuff. All right, we're going to use point slope. Find the intersection of a line with a slope of 4 that passes through 215. So the first thing I'm going to do is write my fill in the blank so I can write the equation of the point. And then, like I said, the way I work through this is slope goes in the middle blank, x goes by x, y goes by y. I do it in that order that I just showed you, so that if I fill it in left to right, things are more likely to go off the rails for me. I'm more likely to accidentally put x where y should go, or something like that. Slope goes in the middle, x goes by x, y goes by y. Now, if we're going to find the intersection between this line and this parabola, and we're going to do this by doing algebra, what I'm going to do is I'm going to solve over here for y so I can plug in here. So over here I'm going to solve for y. I'm going to distribute that 4. And I'm going to add over my 15. Point slope form of a line is a lovely equation of a line. I feel like a lot of times when we teach it, we really stress slope intercept form because that's what you need to graph it by hand. But point slope is lovely as well. And so if you're asked for an equation of a line, you can, this is a linear equation right there. All right, now I'm going to substitute. I'm going to take this guy and drop it in for y, and we're going to algebra our way out of it. We do have a line and a parabola, so this could have one solution or 2. We know something funny happened if we have 3 solutions, right? It'd be a weird line. What do I have to be careful about with x plus 3 squared? Yeah, the 6x. Don't just square the x and square the 3. And that's a big part of the reason you do this unit. I want you to be able to tackle the algebra. I want you to be fast on the ACT with this kind of stuff. But we've also got to remember some of these other rules, the algebra precision pieces that they want. combine my like terms over here before I move across my equal sign. -8. And then I'm going to set equal to 0 so that I can factor and solve. My two factors of -15 that add to 2 are +5 and -3. So that gives me x is equal to -5 and x is equal to +3. Those are my x values. I'm going to plug back in to find my y's. And I'm going to always plug back into the simpler equation. Something that we didn't talk about that is kind of at the beginning of the notes is that every once in a while you can get extraneous solutions. That's kind of why I talked about, hey, we have a parabola and a line. How many ways can that happen? Well, it can be a tangent line, so there can be one point, or it can intersect twice, not 3 times. Every once in a while, if you plug back into the more complicated equation, you're more likely to get extra solutions. They're called extraneous solutions. They just don't fit. And that's where graphing or checking kind of that things are reasonable is helpful. So I'm going to plug in my -5 to this equation. So that's -20 plus 7. That's going to give me -13. We have our x and our y there. There's one of our ordered pairs. And I need to do the same thing with a +3. So I'm plugging into 4 times. So that is 19. So substitution. 2 substitution examples today, 2 elimination examples today. If you want to work ahead, there's a 3rd elimination example. Good so far? You guys can talk to me even though I'm taking a video. You don't have to worry. Do I voice to be embedded? No. This is, I mean, this has to be close. Unless you want it to be. You good? Questions? Okay. All right, so this example, I really like. This is good for a substitution problem. I'm going to do substitution here as well. What kind of shape do we have? X squared plus y squared equals 8. Yeah, it's a circle. And what about xy equals 4? What if I do this? Now what is it? Yeah, well, it's that guy, and this is, it's our 1 over x, just with a vertical stretch by 4. Okay? So it looks, this situation, spoiler alert, one over x looks like this. There are a couple ways this could happen. This particular example, like I said, spoiler alert, and this is going to be the best circle ever. Yep. Oh, not so bad. That's interesting. This is going to have 2 solutions. We're going to have 1 solution in the first quadrant and 1 in the third. Another way this could happen, if this circle was bigger, we could have 4 solutions with the rational function and the circle. So again, just keeping in mind, you guys know a lot about functions and how they work. So just keeping in mind what this is going to look like, even if you're not putting it in your calculator, or even if you only put 4 over x in your calculator, and then kind of try to eyeball where that circle would be. It's good to have that visual so that you can be confident in your 2 solutions or 4 solutions or whatever you have. we are going to do this one, like I said, by substitution. So I'm going to take this 4 over x and I'm going to put it in for y. Now this time, earlier this week when we were plugging in for y, we plugged in for y squared. Here we're plugging in just for y. All right, see if you can get a step ahead. I'm going to put in that 4 over x. Make sure you square that x in the bottom there. Earlier today when I was doing this problem, at this point I said you can clear the fraction or find a common denominator. And I said clear the fraction, everybody said no. And when I said common denominator, they were like, okay. So to find a common denominator here, what does my first fraction mean? Another x squared, right? And so if you like the common denominator, I feel like at this point you guys are comfortable with fractions, but you're comfortable with the rules that we've used a ton. And this is one that we used a ton. So this is going to become x to the 4th plus 16, and it is over x squared now. And I think that is kind of the path of least resistance for continuing and for solving this problem. At this point, I have to clear the fraction. So once you have that common denominator, you have to multiply the x squared over. And remember, when you do that, you're not making this. You're not distributing on top. You're canceling there. So x to the 4th plus 16 equals 8x squared. I'm going to bring my 8x squared over, and we're going to factor. Don't get worked up about factoring if we're doing to the 4th power. As long as you have an even power, you just have to break that exponent up evenly. So if you had x to the 4th, we're doing x squared and x squared. And then the rest of the factoring works the same. If we had x to the 6th, it would be cubed and cubed. If we had x to the 8th, it would be to the 4th to the 4th. Okay, so don't worry about it so much. It works just like you're used to. My two factors of 16 that add to -8 are -4 and -4. This is a fun one because of that. So, x squared equals 4. What does x equal?
2.
What kind of 2 is it?
Positive -2.
Thank you.
I did something very weird. Oh.
Now, if you plug back into the circle equation with your positive and -2, you get extraneous answers. You get extra answers. And so this is a place, and I plugged back into both of them and see, I've definitely had that happen to me, and then graphed it, and I'm like, I have 2 solutions. What's happening here? That's why, again, I would always pick to plug back into the simpler equation, the one that has the smaller exponents. Is going to be the one that's easier for you to plug back into, I think. So I'm going to plug back in here. I'm going to plug in +2, and I'm going to plug in -2. And I'm going to do y equals 4 over 2. And same thing with negative. So like I said from the beginning, this example has 2 solutions, one in the first quadrant and one in the third. Good. 2 substitution examples. Flip your page when you're ready, and we're going to talk about elimination. Do you remember? Oh, we remember doing elimination. That's good. Earlier today.
Subtract y from the equations.
Kind of. So here's when you've done elimination before. In algebra 1, you had something like this. 3x plus 8y equals 6. I don't know. And 1x plus 6y equals 11. and you had two equations, and you were solving for x and y, and your Algebra 1 teacher probably said, now, yeah, I know you can do this like Desmos, but now we need to do it algebraically. And so the way to do this problem without doing substitution is this. We treat it like, I teach it like as addition. I want to add vertically and get rid of a variable. That's why it's called elimination. You're eliminating a variable. Because if we have two equations, we can solve for two variables. But if we're going to get down to one equation, we're solving for a single variable. Now, to do this the easiest way in a problem like this, what we do is make opposites. And that's what we're going to do when we do elimination also. We're going to pick a variable to get rid of and make opposites. And we're going to make the easier opposite. Your easier opposite might be different than mine. When I see 1 and 3, I say I can turn 1 into 3's opposite. How can I turn 1 into 3's opposite? By multiplying by what? -3. Now this is an equation, so if I do that there, I have to do it here, and I have to do it here. What effectively happens is you just turned this whole thing when you add into 0, and now you just have some y equals something. You can just divide and be done. I like elimination a lot in situations like this, where everything is stacked and lined up, because it's more about the pre-work. It's like a puzzle at the beginning, and kind of once you figure out that puzzle, the solving is easier afterwards. Substitution, I feel like you pick something and drop it in, and then you kind of have to sort out the mess. This, you're making it work for you. Like it or not, you see the fraction problem, it's one problem below here. You don't want to do substitution on that fraction problem. So decide to do elimination on a couple, and I really think it will work for you well, okay? Even if you didn't like it when you did it in Algebra 1. So what I want you to look at here is what do we have that is the same between our two equations that are up here. We're going to solve this by elimination. We have a circle and a parabola. What is exactly the same? Yeah, the x squared. And so right now, they're both positive, so they're not opposites. How can I make them opposites? Right, make one of them negative. Now if I do this to this bottom x squared, if I'm going to make that x squared negative, I have to make the y positive, and I have to make the 7 negative. I just multiply by -1. And I do this so I can add, and other teachers will teach this as subtraction, but I think adding the opposite is just a little bit easier for your eyes. And now our x squareds, when we add here, our x squareds cancel, gone. You have to be careful with your y's, because it's not like the last problem I showed you. These aren't all linear. So what I'm doing here is y squared plus y. I can't add those. I can't add them, but I have to add them like that. And then this is going to be equal to 13 plus -7 is 6. So by multiplying that bottom row by -1, or the top if you wanted to, now I have one equation and one variable. I've eliminated x altogether. And now we can solve. And here's the dangerous part. We're solving for y, so make sure I put that here.
I think I'm wrong.
Okay, so I'm going to move my 6 over. Y squared plus y minus 6 equals 0. I'm going to factor. I have +3 and -2. So y equals -3 and y equals +2. And the reason I built these is because now when I plug back in, it's dangerous for me. I'm more likely to flip my x and y. Once we have our first variable solved for, now we're going to plug back in. You can plug back into either equation, like I've said, but I do think you want to pick the less complicated equation, and I usually pick kind of the original version. So the original version of our equation was x squared minus y equals 7. So I'm going to plug in negative 3. So x squared minus negative 3 equals 7. What kind of twos? Positive and negative. So paired with negative 3 is positive and negative 2. If you want to write it as plus minus, you can. You can write it like this as well. So circle on a parabola, it looks like we're working towards 3 or 4 solutions, and that's reasonable, right, for a circle and a parabola. All right, I'm going to do the same thing with 2, y equals 2. Try to organize my work for my sanity and so that you can look at it and have it not look like craziness. Add my 2 over, x squared equals 9. You're going to have a lot of positive and negative cases of the same things going on here because of the squares that you have happening. You're going to see kind of that symmetry happening. Okay, so far? So that was elimination. Have I convinced you that it's like an okay method?
It was always my favorite.
Elimination is my favorite too. My favorite as well. All right, you ready to do the crazy fraction problem? I dig the crazy fraction problem. I know it's not shocking at all. Okay. Take a deep breath. It's easier than it looks. Okay? Our crazy fraction problem we're going to do by elimination because first, I have no interest in solving this for a single variable. And if I don't want to solve it for a single variable, I'm pretty sure you don't either. The other thing is if you see how this lines up, x squared, over x squared over y squared constant. I'm actually going to move the constants over just because I like the constants where those zeros are. The other thing is, if you look vertically here, those are common denominators. So the common denominators are built into the problem. You don't have to find a common denominator, you just have to mess with the numerators. Just like we did back here when we multiplied everything by -1, or just like we did here when we said, oh, we'd multiply everything by -3. We don't have to do anything to the bottoms of the fractions. The common denominators are built in, which is really nice. So, I am, though, going to move over. Like I said, I'm going to do this, and this is just maybe just a personal preference thing. It works, even if you don't. But I'm going to rewrite here. So 2 over x squared minus 3 over y squared equals -1 over 1. You guys know if I have fractions, I go all in. And then down here, 6 over x squared minus 7 over y squared equals -2 over 1. And like I said, our fractions, our like fractions, have common denominators. So now we can just look at what we can turn into kind of to match. I'm looking at the x's here. I usually like to solve for x first, but can I turn 2 into the opposite of 6? By multiplying by what? Okay. And if I do it to this first term, I have to do it to everything. Right? And I'm going to rewrite before we eliminate. I feel like these problems end up being very, like, I don't like how tall they are. I know that sounds silly, but. So we have -6 over x squared. And this -3 times -3 is +9. over y squared equals negative 3 times negative 1 is positive 3 over 1. And then I'm just going to recopy that other equation, but now we've written it a couple times. 6 over x squared minus 7 over y squared equals negative 2. And again, I set it up as addition. If you want to set it up as subtraction instead of doing the opposite, you can, but I think addition. All right. Watch this. Goodbye. What's 9 minus 7? Yeah, and that's the work we're doing here because these have common denominators. So don't make it harder than it is. You're doing 9 minus 7, 2 over y squared equals 3 plus negative 2. Cross multiply. 2 times 1. Y squared times 1. What kind of radical 2's do I have? Plus and minus. The other nice thing about these is that when we plug this back in, we don't have to plug in the positive case and the negative case. You can plug that whole thing in as one because what we're doing, and I'm going to plug back into this original equation right here. When I plug in there, what's the first thing I'm going to do to radical 2? Square it. So does that matter if it's positive or negative? It's going to turn positive right away. And so when I plug back in, so I have 2 over x squared minus 3 over radical 2 squared. I'm going to go ahead and write it as plus or minus radical 2 for myself. Equals negative 1. And now when I square the positive or negative, I get positive. And when I square the radical 2, I get a 2. I'm going to add 3 over 2 to the other side. Remember, 3 over 2 is just 1.5. So it's negative 1 plus 1.5. 1/2. 2 times 2 is 4. 1 times x squared is x squared. What kind of 2's? Positive and negative. You have 4 solutions on every problem like this. You're going to have 4 solutions on. You're going to have the positive, like positives, positive negatives. So I'll write those out for you, and then I'll take some questions. So positive 2 is going to be paired with positive radical 2. Positive 2 is going to be paired with negative radical 2. There's my x's and there's my y's. Negative 2 is going to be paired with radical 2. Negative 2 is going to be paired with negative radical 2. I like it.